slides. I have a few slides coming up, I hope. So my name is Joe Phelan. I'm a larval ecologist. I work as an applied scientist for Tenera Environmental. Very much at the project implementation stage. I received my PhD from St Andrews University in Scotland in 2007 and have since worked in the Middle East on combined power and desalination facilities, and in the UK as a policy advisor to the UK government on nature conservation policy in this field. So I'm very excited to now be working in California for Tenera on this work because, and I'd like to commend the staff and stakeholders involved in this desal amendment. It really is, as somebody said earlier on, quite precedent setting on a global scale from my experience, in that California is trying to really get to grips with this issue of desalination intakes. So my presentation today is going to be primarily focused on the intake question. I know there's a lot of other issues addressed in the amendment in relation to discharge and other things. And what I'm hoping to present to you today is some examples at a project implementation level of how you can consider siting as such an important aspect in relation to intake entrainment effects. The key message here that I want to put across is that really not all sites are equal. California's coast is very diverse in terms of its biological environment and its physical environment. By that I mean geology, oceanography. We're all aware of that here, I'm sure, and we all greatly appreciate that. On my slide up on the board right now, you can see an image of the Monterey Bay area and the Monterey Bay Submarine Canyon, which is a large geological feature that cuts into the continental shelf and reaches almost all the way up to the beach. I mean, you can see how far into the coast it goes. It's a very unique location in the world. It's a very large submarine canyon. There are other submarine canyons, but this is a particularly large one. And this provides the opportunity for siting and intake potentially that could reduce entrainment effects quite substantially. So I hope to highlight that very briefly now. The three things that I'll be showing you is we've identified that there are less larval fish at deeper depths. So if you can access them, then that provides some benefit. There are, it seems, bigger larval fish at deeper depths, at least for certain species, and I'll explain the benefits of that hopefully very briefly. And we've also identified some other oceanographic phenomena that may be unique to canyon heads or may be unique to this canyon head. We don't know exactly, but we do know that there is some interesting oceanographic features here that I can elaborate on a little today. So next slide, please.
You don't have a ton of time unless all your slides are being shared with the people after you.
I'm sorry?
You don't have a lot of time, and you have a lot of slides, so you can't get through all these slides, I guarantee you.
So on the left side there, I'm just
So I'm just saying choose your slides carefully, because
Okay.
you're not going to get more than your time, but you can share them with the people after you.
Okay, okay.
They're very interesting, but...
Thank you. I'll go through them very quickly. So on the left side there is some data we collected showing less larval fish at depth. On the right-hand side there is some results from our analysis showing increases in size of larval fish. The benefits of that are that screening would be more effective if you can go deeper in the water. And the final slide that I wanted to show there was we identified this oceanographic phenomenon known as an internal tide at the canyon head, which pumps cold water up onto the shelf at this location. It's a fairly unique feature of canyon heads driven by the tide. The implications of it are that cold, deep water is very larval depauperate. So the point that I'm trying to show here is really that siting can have a significant impact on a significant effect on reducing entrainment. That's it. Thank you.
Oh, yeah, I had a question. I actually went to Hopkins Marine Station at Stanford University, just down the coast from here. And it was really exciting. I was wondering if you've had a chance to coordinate with scientists at the Monterey Bay Aquarium Research Institute about their deep sea biology research that they've conducted in the last 5-6 years.
Yeah, I think everybody knows about MBARI and their fascinating discoveries of deep sea communities. I would say, to give this some perspective, the depths that when I say deep, I'm talking relatively deep, 40 meters maybe. The depths that Mbari are working at with these incredible deep sea communities are, in the thousands. So we're talking of a different scale.
Hundreds to thousands. And good. And just FYI, there was a lecture on the cutting edge research there, discovering new species every year. And this last Friday there was a lecture from. Have you coordinated with Bruce Robeson about some of the like the unique life cycle characteristics of this deep sea biology of the Monterey Canyon?
No, I have to say there isn't an element of the deep sea biology related to this intake, just because, as I said, we're dealing with shelf waters, generally speaking, which are, the kelp forests and seabed communities of larval fish, for example.
Yeah, so you'd say this is a zone. It's not the upper zone where a lot of the proposals we've seen are located, but it's not at the canyon level zone where you think it would affect other life stages of that biology.
Precisely. When we say a deep water intake, we're not talking thousands of meters here. We're talking tens of meters. So maybe doubling the depth of a typical California intake.
Okay. Yeah.
But you just dive under that productivity level a little bit, and you can see significant reduction.
Okay. Good.
A couple of questions. You may want to answer the question I want to ask, which is, we did have an expert panel looking at this at some length. I was going to say at some depth, but at some length. You can never get away from it, really. But so did they look at this kind of an issue, number one, and number two, is this the kind of thing that would play into a regional board's consideration? I don't want to open a door again. I'm just a hangover from yesterday. Don't want to open any doors that a Mack truck can go through.
So if you look at the expert panel findings back from, I think it was the first expert panel on intakes and mitigation, citing something in the offshore environment or a deep water environment where there's not as much marine life could minimize intake and mortality of marine life. However, relative to a subsurface intake, something like a horizontally directionally drilled well that may have no impacts on marine life, you're still comparing it to zero. There's a couple of other considerations that raise concerns. These are species that aren't well studied. They're just now identifying them when they go on their cruises. So he did say it's relative, but it does raise questions as to if these are truly species that aren't as accessible and aren't as well known. What's their reproductive life cycles? How does that play into productivity? How do you mitigate for that? And then I did have a question about the previous slide. Can you just...
Yeah.
So my question is about the assertion that larval fish are larger at deeper depths.
Yeah.
Is it based on this data set alone? Because when I look at this, you can see the mean difference is fractions of millimeters. And then when you're looking at the p-values, it's a 90%. So that picks up 3 out of 6 fish. So that's half of the fish. But then if you were to use a 95% confidence interval or confidence level, that drops off blue rockfish and croakers, so you're left with speckled sand dabs. So I'm curious as to, is this the complete data set, or is this for the slide to just show that this is a trend that you've seen?
So this is from data that was collected over the course of a year, multi-survey trips, so throughout the year. I think we have 14 surveys through a course of 12 months, maybe more than that. And the analysis that's done there is essentially a paired ANOVA, kind of like a paired t-test. And so whilst those mean differences in length look small, because you're pairing samples, so you're taking a shallow and a deep sample each time you collect data, that's why you can see that significant difference when maybe you would see the mean differences as being relatively small. Sense?
Who else has a question?
Well, I think it would be helpful if you have a written copy of the PowerPoint presentation. Some of this information is brand new for staff for the first time, so we might want to take a look at it. And I'm not sure if I understood the answer to the question whether this particular chart reflects all of the data that was collected.
The particular chart reflects all of the data that was collected for those 6 taxa that you see listed: anchovies, blue rockfish, croaker, KGB, Pacific sandab, and speckled sandab. So they're the fish that were analyzed in this work. There are obviously other fish in our samples, but we chose these fish for a number of reasons, which I can go into in more detail if you'd like, but primarily just for their abundance.
Just to be clear, though, the study itself was not submitted to the board, was it?
This has not been submitted. This is fresh off the press.
So I'm just thinking that sounds like this is new information, and without a doubt, as time goes on, there'll be even more information. The question seems to me is whether or not the language as proposed by staff would allow you to present this information to the regional board and have it be considered. So is there something in this language that you feel precludes you from being able to present this information and make the comparative analysis?
I think in terms of the desalination amendment that's being presented and discussed today, I really just brought this information to highlight the importance of flexibility in a policy. It allows for this kind of innovative approach to planning and permitting desalination facilities. So I think Jared maybe talked about that a little bit more in his, and I think some others will talk about it again, particularly in relation to the desalination amendment language. But I really want to just highlight this to show that a flexible approach to policy will allow for that innovative approach to planning and permitting on these desalination facilities. The counter to that would be an inflexible approach, may constrain some of that innovation and drive you towards other decisions.
And Mr. Wiles, could you comment?
Well, it sounds like he's not actually suggesting that there's any language in the amendment that I'm hearing anyway needs to change as a result of this. He just wanted to bring it to the board's attention. Is that accurate?
I must admit, I'm not yet drawing attention to any specific changes in the language now.
I think other people are more focused on the language.
That's correct. I'm just here to present some science.
Focused on presenting this issue to us. Okay, thank you very much. Next, John Steinbeck, also with Tenera, followed by Scott Jackson, also from Deepwater Desal.
Thank you, Chairwoman and board members. My name's John Steinbeck. Actually, my slides follow the...
That's where I was confused, because I have it in one place, so I thought, sorry, Mr. Phelan.
Yeah, mine just follow Joe's. I'm with Tenera Environmental and representing Deepwater Desal. I've worked on intake and discharge issues associated with ocean intakes for 35 years, including most of the desal projects in California, and have served on the expert panels for both OTC and the desal. I commend the board on the amount of good science that's been incorporated into the latest draft of the amendment. But in reading through the SED, it seemed that there was still some questions regarding and even confusion on the use of ETM and APF, and therefore I wanted to discuss how ETM and APF are used in intake assessments, and also how it relates to the text at the end of section 2E1A of the amendment on the application of APF. First of all, I believe that the emphasis should be on ETM, not APF. The first step in any assessment should be the evaluation of the ETM results. For example, data from the Deepwater Desal study that Joe briefly talked about showed losses of about less than 1/100% for 2 groups of rockfishes for the estimated intake volume of 46.5 mgd. There's no way these levels of additional mortality on the populations could affect these fishes. This was recognized by the scientists on the expert panel and was really one of the reasons we recommended that studies not be required for small to medium-sized desal plants and this fee-based approach be used. But I support the decision to use some sort of compensatory approach to, compensating for these losses. One of the problems in the amendment I see is that APF rather than ETM is being treated as the primary approach to impact assessment, and improperly used, it can actually distort the results of the ETM. The approach specifically for the section of the amendment I mentioned ignores the complexity of the ETM estimates that are really the basis for the calculation of APF. I don't want to get into that equation up there, but all those highlighted parameters have variance associated with them. And so treating the APF as data with calculating confidence intervals as you would with a pollutant just is not correct. Next, I got the slides, huh? Oh, okay. So the approach in section 2E1A would be appropriate for dealing with data on levels of pollutants, but not estimates of APF that are derived from ETM estimates that are already conservative. The larval durations are calculated using a 95th percentile of the measurements for the lengths of the larvae from the study, and this increases the estimates of larval duration. Larval duration is important because it's used in calculating the level of mortality and also the source water. A comprehensive study of larval durations from numerous planktonic organisms showed that in almost all cases, the types of modeling we do to estimate source water, which are the gray line and the line underneath it, will overestimate the dispersal distance. This leads to larger estimates of source water than what is probably likely occurring. And this is largely due to larval behavior and complexity occurrence that you just can't incorporate into these models.
And now you actually do have to wrap up.
Yeah, I'm trying to, there we go. Also mentioned the misapplication of APF, and this slide shows some of the data from the Deepwater Desal study. We actually estimate the source water for rockfishes in this case using back projections of CODAR data, the methodology that the staff mentioned, and it gives us a more accurate estimate of the source water. But the actual areas of the source for these fish are those orange shaded areas, and so the actual source areas that should be used in the APF are the intersections of those back projections in the orange, not that whole red outline, which is what's been used in some of the studies in calculating APF. Therefore, based on these issues with the use of ETM and APF, I would encourage the board to just strike that text at the end of that section that I actually mentioned in my letter of April 9th. That adds unnecessary specificity to a project that is unlikely to be, it's unnecessary and also unlikely to be achievable based on the data that's collected. Thank you.
Thank you. I want to ask staff to clarify your thinking and respond to that, because I know you've been spending a lot of time on this.
So just to give a little backstory on the 95% confidence interval, in I think probably the first draft, it's too long, I can't remember, but I know that at the August 6th, 2014 public workshop, this issue came up where people were concerned that the ETM APF method would not, is this really going to provide adequate mitigation? And so one of the things, Dr. Pete Ramundi, who was on the expert panel, Mr. Steinbeck wasn't on that panel or panel 2 or 3, but at that meeting, Dr. Ramundi said you could add a confidence interval to help when there's statistical uncertainty associated with the analysis. Now, in the Tenera April 9th comment letter that we received in the most recent round of response to comments, it was mentioned that there is the Tenera and the Water Reuse Research Foundation are working on improving the ETM APF method, so finding out, and maybe Mr. Steinbeck can elaborate more on the exact nature of that document. So there's a document that's coming out that should provide more information regarding how to conduct a proper ETM APF analysis. However, Mr. Steinbeck and Dr. Ramundi are having a disagreement on the application of the statistical application of the APF. So because there's a disagreement that has yet to be resolved, we don't have the report yet. The issue hasn't necessarily been resolved, and it probably will be resolved sometime in the future. Staff was recommending taking a precautionary approach rather than just strike the confidence interval completely, but maybe come back and revisit this issue when there's more information and we have experts who have a better understanding of what they would like us to do. The board has required statistical or added confidence in the past to allow for statistical uncertainty on other board action items. The environmental stakeholders urge us strongly to include it, as did the Coastal Commission. So at this point, until the differences can be resolved in the correct application, I would recommend keeping it in. Now, nothing in the amendment prevents somebody from doing a better ETM APF analysis. It just says that you need to conduct one. The emphasis isn't on APF, but it is a useful currency for telling somebody how much they need to mitigate. So ETM's a part of that, but they're coupled. And so we're looking to scientists like those at Tenera and other agencies that conduct these, like NBC, really be the scientific resource to tell somebody who's required to do the study how to do it best. But we don't think that there's anything in the language that really prevents that. And then, the added statistical certainty is there until somebody figures out, they can demonstrate that it's not necessary, and we have that on the record.
Yeah, I'm not going to get into an argument, but if
if
you just want to clarify, and then we have to move on. We'll hear from everybody, and
I
then
was
we'll
just
come back.
going to say I've spoken to Dr. Ramondi about this, and he agreed that there was some issues that we should work out, and we had actually intended to do this months ago. We just haven't had an opportunity, and so there is the intent to work this all out.
Great. Okay.
That's
Thank
great.
you. That sounds consistent.
I just had a quick question on that, and you can think about it, as the day goes on, kind of thing. But I was wondering if that phrase, because it is fairly emphatic, it says the APF shall be calculated, et cetera. Is there a phrase that can be inserted before then that says something along the lines of unless a more certain estimate of APF is available, and then the APF shall be, because what Ms. Wagner was getting at was, if we have a more certain representative value, then we don't need to use the statistical estimate. Right. Would this be useful?
I think some language that, taking out the 95% and just saying the approach used to arrive at the final mitigation should incorporate any uncertainty in the estimates, and something like that would kind of take care of it.
Right. Well, I know that was your suggestion, but I'm trying to find maybe a middle ground where we have a default that has been worked through by many stakeholders' input, and if we can point to something that we can do in lieu of that default, maybe we get to something that to you it feels more scientifically justified.
Yeah, it's one sentence. No, I just think the way it's stated right now, there's some question as to whether it's even accurate.
Okay, no.
Excuse me, can I ask a quick question? So, my understanding from what you're saying, and limited understanding, I'll admit, is that by adding the 95th percentile confidence interval, we are unnecessarily restricting or adding additional compensation needs. So you're increasing the amount of compensation you would have to do based on that significantly and unnecessarily. Is that what you're getting at?
There's that, but also I think you need to look at the underlying components or the data that went into the ETM, and not all the estimates from all the species are equal. And so it's a little more considered than just taking a whole suite of estimates from a list of species and coming up with a 95% confidence interval on the mean of those APF estimates. These estimates are already conservative, but I think there's some need to look at the range of estimates that have been calculated within a study and see which are the most appropriate, and maybe you increase it, but by some percentage based on the kind of the level of uncertainty associated with the estimate, not a statistical measure that I think has some questions on the validity of it.
Thank you.
Thank you very much.
Thank you.
Scott Jackson for Deepwater Desal, followed by Brent Constance, also for Deepwater Desal.
Madam Chair, I wondered if I might indulge the boards by allowing Dr. Constance to go before me.
Of course, of course.
Thank you.
Fine.
Oh, I see. You all had all your slides together. That's why. I'm sorry, Dr. Phelan. I just thought, man, how many slides can you do in 3 minutes?
Yeah.
Sorry.
You'd be surprised. Thank you for hearing our comments. My name is Brent Constance. I'm with Deepwater Desal. I'm also a consulting associate professor at Stanford. I've been working in marine science and specifically carbonate chemistry for about the last 35 years. I have over 200 publications in this area.
You're going to freak me out about ocean acidification too today? Please don't.
Well, we should be.
I am.
I want to just emphasize that this is a really needed policy, and most of it's exactly what's needed. We don't really have a lot of changes. You know, we agree with everything on the discharge part, and you know, obviously, you know, we know at Moss Landing, citing a shallow water intake in an estuary is about the last thing you ever want to do. You know, and nobody has any disagreement on most of everything that's being said here. But I want to note, you know, we've been working with this process for over 5 years, and you know, this is Dominic Gregorio's slide from 2012, and at that time it was technology neutral. You know, we all realized you had to lower impingement and entrainment, and you know, subsurface where appropriate was considered by the state board. Wedge wire screens, if they could work. Deep water intakes were listed. You know, then there were a lot of approaches, and then in 2013, if I can get the next slide, it was divided. This is Dominic's presentation in 2013, and we went to all these meetings and presented all the information, you know, talked about greenhouse gases, everything. It just never got reflected in the policy, but and there was 2 tracks. There was subsurface, and then there was surface, which included deep water intakes, and so it made sense to be conducting all these oceanographic studies. But site selection is really the biggest lever you have, you know, way before technology. You know, we all know going in a lagoon is a bad thing to do. You know, we know any shallow water intake is likely to have significant impacts because it's in the photic zone. You can't avoid that, and there's hardly anything you can do with good technology to avoid that. But to lump everything in, and now the way it's done is they've lumped in the infiltration gallery with subsurface intakes. And of course, the way it reads is subsurface intakes have no environmental impact. Next slide. And so if you look at it, if it impacts on all forms of marine life, actually the impacts on all forms of marine life I would consider highest amongst subsurface intakes with, you know, considering the greenhouse gases. You know, in Monterey, we have the largest power plant in the West Coast, putting out 2 million tons of CO2 a year. So, you know, the comment was made was greenhouse gases or some other issue. It doesn't have anything to do with the mortality of marine life. In fact, the pH of the ocean right off that power plant where there's a lot of CO2 coming out is below 8. Now, and
you know, I'm interested in how you would mitigate against ocean acidification. You know, there's ways to mitigate against, you know, less than a fraction of a tenth of a % of fish being intaken, but how do you mitigate against Monterey Bay already being below pH 8? And I wonder about that, and I think that I just have never seen any data to suggest that a subsurface intake, especially, you know, even without the greenhouse gases, actually lowers the impact on marine life. So
can you just address directly the slant well idea? If you're using a slant well to bring in water and not a infiltration gallery, you see no difference between the two?
Absolutely. In fact, I'll get to that. So, you know, there's a slant well being drilled down in Monterey now that I believe goes to about, is planned to go to 270 feet. And it's going to be going from, you know, over 10 bars of pressure up to the surface, which is akin to opening a soda bottle. And when all those bubbles come out, that's all CO2. An infiltration gallery doesn't have that issue because it's just right below the surface. So an infiltration gallery is a type of subsurface intake where you can avoid greenhouse gases.
So you're saying a slant well is worse than an infiltration gallery for GHGs?
Well, probably also for all forms of marine life. I mean,
okay.
If you look at most of the life in the ocean is microorganisms, right? And the water column has fairly low faunal diversity because it's homogeneous. The subsurface fauna is very diverse because it's so heterogeneous. And there are actually many more species that are going to be destroyed through subsurface intakes than through a water column intake. I'm not in favor of shallow water intakes, don't get me wrong. I think it's, you know, you're doing the right thing. But subsurface intakes, wells are even worse, especially when you consider the greenhouse gas implications. You know, that power plant there in Monterey is putting out 2 million tons of CO2 a year, and the pH of the ocean is already below 8, just locally to Moss Landing. You know, and Bari's there. We know this really well. These guys did good studies. You know, these wells are going to, the ones that they're thinking about down in Marina are going to put over 200,000 tons probably, you know, CO2 into the year. That's, you know, tens of thousands of cars. And that does affect the pH. And I want to know how you propose to mitigate against that, because this policy talks about how you're going to mitigate against open ocean intakes. This was just the discussion, but it's assumed all subsurface intakes, including infiltration galleries, which I don't think anyone here would argue have some environmental impact, have no form of impact and therefore need no mitigation. That just doesn't, I don't understand that. You know, that's all I can say. But moving ahead, you know, the scientists at Lawrence Livermore Labs at the University of California, Stanford, you know, wrote to the state board about, look, there's a real issue here of greenhouse gases, and the board commented that, well, we did our own calculations and we think it's insignificant. And that's understandable. Nobody did anything wrong. It turns out, and the EPA is very aware of this, and people in the geochemical community, again, it's like uncorking, you know, opening a bottle of soda water. The water comes up out of the well. First thing it does is it all exsolves into the atmosphere before you can even get a sample. So by the time the samples get to the lab for analysis, the actual CO2 level you measure in dissolved organic carbon is about 100th or more what it really was, because it's already off-gassed. So I understand why their calculations from published values, which are all collected that way, were only 1,000 tons of CO2 a year, which they deemed insignificant. It's actually more like 100 times more than that, you know, is likely. And I have to remind you, the CARB levels of significance are 10,000 tons of CO2. You're in the registry, and 25,000 tons CO2. You're in mandatory cap and trade. And, you know, to say that a few thousands of tons are insignificant, even that doesn't make sense to me. It is significant, but hundreds of thousands of tons is definitely significant. You know. So I think that's a really important point to think about.
Right, and I think the point staff made is where that mitigation takes place or consideration takes place. And I'm not negating the issue, but you have to wrap up because you're going way long.
Okay. Well,
I know we've asked some questions,
but you know, that's like, you know, visual corridor and things they don't, because it doesn't affect marine organisms. And I'm just saying that's absolutely false. At Moss Landing, we're seeing changes from the CO2 emissions locally. There are local effects to ocean acidification. It's not all the same as Mauna Loa. So, and I'll just wrap up saying I think it's a great policy. We have some proposed edits we've already submitted, so I won't go over those. And in my last slide, I'll just comment that there are ways to avoid greenhouse gases, such as with infiltration galleries rather than wells that go below about 10 meters in the substrate, where you're not going to be pulling up gases from deep pressure that are going to exhaust. Thank you very much.
Thank you. Steph, is there any clarification you want to make after that?
I'll start and then I'll kick it over to Paul and Frank. I just wanted to clarify that the amendment clearly states that an owner-operator mitigate for mortality of all forms of marine life. So it doesn't assert that subsurface intakes are without environmental impact.
Right, I was going to ask that because they would have to mitigate for that as well, right?
Yeah, if there's construction-related impacts, then those need to be mitigated for. All of the evidence that we have supports that there's zero entrainment through a subsurface intake, so there's no entrainment-related mortality, there's no impingement-related mortality associated with those, and so anything would be construction-related, and there are situations where there's no construction-related impacts depending on how you site it. So.
And where does the GHG analysis get taken? And we already talked about this, but just.
I'm going to hand that over to Paul and Frank.
So there's a couple of different parts to that. The first one is, you know, whether or not we've done an adequate job of looking at the emissions from a CEQA perspective and the question of significance there. And I will say that we've looked at it from our end. We believe that hypothetical emissions at the level that we can determine them, not knowing site design technology or other site-specific set factors, that we're looking at emissions on the order of 1,000 tons per year, much less than what has been identified, you know, as the CARB threshold and whatnot. As to whether or not those emissions that are published in the literature are low relative to what they are actually, I don't know that we can speak to that. That's new information. We'd have to take a look at it. I will hand off to Frank if he wants to weigh in on it, but I don't believe that was something that addressed within the literature that we looked at. I think it's important to note, though, that there's a lot that we did in those calculations that is fairly generic in nature. When the plants are actually proposed, they will have to go through another level of CEQA. This was identified by Phil. At that time, there are a number of different sources of greenhouse gas emissions, amongst other impacts that will need to be assessed. At that time, should there be an issue with the overall levels of emissions, many of which would be handled by other agencies, that's certainly something that could be used to declare a subsurface infeasible, but I don't see that the information that we have at the moment would declare them categorically as infeasible.
When we first received the comment about greenhouse gas emissions from subsurface seawater, we admitted we did not address that, but the estimated amount of 200,000 tons per year from a 50 million gallon per day facility seemed really excessive, since the CO2 produced from the energy required to run the plant runs from 80 to 90,000 tons per year. And so the commenter cited a paper that I went back to and she looked at 5 different types of water. We don't need to get into chemistry of water, but the amount of CO2, that's actual CO2 in water, is dependent highly on the pH. And she looked at 5 different classes of water. I took the worst case scenario, which was reported in millimoles per liter, and extrapolated it up to a 50 million gallon per day plant over a year. And I came up with just over 1,000 tons of CO2 per year, which seems a lot more reasonable to me. If CO2 outgassing from groundwater pumping really produced that much CO2, we are pumping millions and millions and millions of gallons of water in this state all the time. That source of CO2 is not on CARB's, the Air Resources Board's radar, and it just does not seem logical that that amount is actually being produced. I can get from the commenter's assumptions, I can get from his 1.5 kilograms per cubic meter of water up to the 200,000, but I can't get from his assumption of 0.1 atmosphere, partial pressure, excuse me, to 1.5 kilograms. And his response to our response was he doesn't agree with our calculations. But I never got any more further clarification of how he actually approached that amount.
Well, presumably there's an issue that in general, you're right to look at it compared to everything that's going on in California that will be evaluated in other fora as well. So I think that's enough for now. I don't mean, I'm just trying to move it around. That was it's interesting, and there's a place for it, and I know we'll come back, but I want to try and get through the speakers. We need to take our lunch break at 1:10, and we'll take a break until 2 o'clock. So hopefully we can get through the speakers and get some feedback to the staff before them, because it would be nice to use the lunch break. And if we haven't finished that at 1:10, I'll confer with my vice chair about it, because I'm the one who has to go. And then I'll be back. I don't want to miss anything if I can help it. Thank you. Mr. Jackson, followed by John Bond, also Deepwater Desal.
Okay, Madam Chair, members of the board.
Stay close to that mic so we can hear.
There we go. My name is Scott Jackson. I have more than 35 years experience in the desalination industry globally. I have been involved in the project management of, something on the order of 50 or 60 major seawater desalination plants globally, including the first two that were built in California at Diablo Canyon and Gaviota. So I come from the perspective of the guy who was responsible for actually building these things and executing projects. I want to just take a few minutes and discuss this issue of feasibility and the concept of rebuttable presumption. It's clear in the language that the preference is for subsurface intakes, and that before an open ocean intake can even be considered, subsurface intakes must be deemed to be infeasible. And I would just point out that, as an observation, not as a criticism, but to the best of my knowledge, there is no science that really supports the presumption that subsurface intakes have zero harm to marine organisms. And I think that there are a lot of reasons why that presumption may not be correct. But I don't want to go...
Okay, if you don't want to.
I'm sorry to be interrupted.
No, go ahead.
But I don't want to go down that path right now. But it's important, I think, for everybody to understand that there is no credible science that supports the presumption that subsurface intakes cause zero harm to marine organisms. Now, getting back to the feasibility issue, proving the feasibility or infeasibility of a subsurface intake, and keep in mind that there are different types of subsurface intakes. It's not a monolithic technology, and all of those different methods have different impacts. But aside from that, if you're looking at a subsurface intake for anything other than an infiltration gallery, it's not straightforward to demonstrate the feasibility or infeasibility of it, because the only way to do that is to put a hole in the ground. You can't do it by modeling. You have to drill a well. You have to then pump that well for an extended period of time, at least a year, in order to determine whether or not the water quality that you're getting is in fact ocean water, and the chemical characteristics of that ocean water in order to do the design for the seawater desal plant. So there's permitting, there's the time to build the well, there's the pumping time, and it adds considerably to the time frame to develop a plant. Now, just to take that one step further, we know in the industry,
And then try to summarize.
yes, I will, that when you develop a well field, it's going to take more than one well. So if you put 10 or 15 or 20 wells in a well field, it is very likely that you're going to get different water qualities out of each of those. So I just want to make the point that that I would suggest that the board carefully consider the heavy weight that it's given to the presumption that subsurface intakes are the best available technology for withdrawing ocean water, because it may very well not be. So thank you.
Thank you. Mr. Bond, followed by Kyle Jones from the Sierra Club.
Madam Chair, members of the board, it's a pleasure to be here. I have not been in here since I was a member of the Public Utilities Commission, charged as the Water Commissioner. And so it's a pleasure to be back. Thank you all for taking the time to listen to us. I've been involved in the policy process in a number of different capacities, certainly at the PUC. I spent 7.5 years at the Treasury Department, and so the policy process is familiar to me, and believe me, I empathize with you to try to get some of these things right. It's a very difficult process. It's an agonizing process, and I'll say you have both my sympathy and my respect going forward. I want to make only 2 points, and they are as follows. We hope that we have today presented the science that will cause some additional thinking and some further reflection on this presumption of the subsurface intake. What we're trying to do is provide a science-based program and an installation. We have spent a lot of time, and I applaud your staff because obviously they have spent an enormous amount of time going back and forth. But I would just caution that as a policy matter, my cautionary note is to avoid a premature presumption. Somebody made the comment that this is your one chance to get it right. These things are moving so fast that the technology is increasing, the speed of decision making is increasing. So what we're pleading for is a site-by-site evaluation. It is our sincere belief that because of the diversity of the sites up and down the coast of California, that the best way to achieve the goal that we're all trying to achieve, namely minimize the impact on marine life, is better achieved by looking without a presumption, but looking at the science, the site, and the technology that is being offered up. We have a drought problem. We have a number of problems with respect to water supply that we are all familiar with, but what we're pleading for is the opportunity to present the best science around the best site and the best technology. Thank you.
Thank you very much. Mr. Jones, followed by Heather Cooley from the Pacific Institute.
Good afternoon, Chair, members of the board. Kyle Jones with Sierra Club, California. We don't think desal is necessary given the cost effectiveness of conservation, water use efficiency, and wastewater recycling. And desal has many negative effects, as we've heard, on fragile marine ecosystems and is energy intensive, creating greenhouse gas emissions that will further fuel droughts in the future. That being said, if desal is to be done, it should be done correctly, and we appreciate the board's thoughtful approach to these amendments today. We wholeheartedly support the changes provided by Coastkeeper seeking clarification. Subsurface intakes are the best way to minimize intake impacts on marine life, and a strong rebuttable presumption should be created to ensure this greatest possible protection. Minimizing impacts to marine life should also seek multiple siting options. Without requiring numerous sites to be considered, the presumption that we have could be, for subsurface intakes, could be defeated simply by choosing terrible sites. Without comparing numerous sites, we can't be certain that we're actively protecting marine life. And then we would like to commend staff for doing a great job in refining the factors for subsurface feasibility. The factors should be those that are consistent with the choice being made. We support what was taken out in the change sheet and the remove factors and further removing the factors that Sean mentioned previously with Coastkeeper. And we'd just like to add that, if a project can't mitigate greenhouse gas emissions and minimize marine impacts at the same time, that's a bad project, and we think that should not be considered going and should not go forward. Thank you.
Heather Cooley, followed by Connor Everts from the DSAL response group. Ms. Cooley, hello.
Hello, thank you. Thank you for the board for your work on this and for staff for your work on this issue. I know this has been a very busy couple of days and we're getting to the end, so I will make my comments brief. We've talked a lot and heard a lot about the intakes, but I would like to offer one thought for your consideration related to the preferred technology for brine discharge. So the current draft states the preferred technology for minimizing intake and mortality of all forms of marine life resulting from brine discharge is to commingle with the brine with wastewater that would otherwise be discharged to the ocean. I have two concerns with this. First, I would argue that treated wastewater is not a technology, it's really a management practice. But second and most importantly, I would argue that it should not be the preferred option. Treated wastewater is a resource. It's one that's become increasingly important in California as pressures on river streams and aquifers have intensified. It's a resource that should not be wasted by commingling with brine. I feel that it's short-sighted and it runs afoul of both the board and the state's efforts to promote recycled water in California, and request that you reconsider identifying commingling with wastewater as a preferred technology for brine discharge. Thank you.
Steph, I have a question on this because, again, taking the longer-term view, as people start recycling more water, you may end up in a situation where it's still an okay brine disposal, as one of the earlier speakers said, but is there a way to put at present? Or even put some language in acknowledging Ms. Cooley's point off into the future? I mean, I know it's kind of ocean discharge centric at the moment in doing the policy, but she is right in the long term.
She is right, but I think we already...
I don't think you exclude it, but yeah, help me understand it.
So I'd like to point out two things. It says that would otherwise be discharged to the ocean. So as Ms. Patricia Chen mentioned earlier, in some cases the wastewater might not be suitable for water recycling. So if it's going to the ocean anyways, this is a method for minimizing intake and mortality of marine life. And second, the last line in section is 2D2A. Says nothing in this section shall preclude future recycling of wastewater. So our idea, or the thought behind this, is that if a proponent was proposing to commingle the wastewater with the brine, the regional board could conditionally permit them on the fact that that wastewater is available, and when that wastewater becomes unavailable, they would have to either install diffusers or come up with another option. But even without a conditional permit, nothing in here prevents somebody from putting that water to a different use. And at that point, there are alternative technologies available for somebody to switch over to.
I want to get through the cards before lunch. Mr. Everts, followed by Sarah Amizada from the Coastkeepers.
Good afternoon, Connor Everts, representing the DSAL response group. I don't have a musical tag for this one, maybe a dirge. So at this point, I have to respond to what was just said. 2.7 million acre feet every year of treated wastewater are dumped into the Southern California Bight. I don't know that there is any unusable portion of that. I applaud agencies that are here, like West Basin, for the work they do in Orange County. But the whole issue really now, and after hearing yesterday the discussion between supply and demand, is what our priorities are here and what we do first. And at risk of blowing the offer for a ticket to the Cal desal mixer afterwards, I would say this is a case of it's not the technology, stupid. We're really talking about policy and water policy here. And we have some good examples of what happened in Monterey, and I participated in the Division of Ratepayer Advocate stakeholder process. That's what we should have done everywhere first. Australia did it the other way. In the midst of the crisis, they built 6 plants, 4 of them sit idle, and they're paying billions for those plants, partly because of cost, partly because of a conservation ethic. People use a fraction of the per capita we do in this state. So we don't want to repeat that mistake here when we have the opportunity to do it right. I've been working on this since 1989. There have been only really 2 small plants and now 1 large one moving forward. But things can change very quickly, and with a tsunami of media response we have all felt. I got 4 calls just today, starting at 6 a.m. The interest in water resources has never been higher, and the possibility for change, things that really matter, like groundwater change and the structural changes that they made with water rights in Australia, are available to us. But if we think of this as an endless reservoir, as it's been called by the industry, or that we think of this as a way of saving us from ourselves and our current water habits, then we've missed the opportunity to set priorities. So as far as Monterey and what happened there in the stakeholder process, what I really want to talk about is need, and that's what I'm referring to. We don't go through that process beforehand. What we ask only in this is that it is identified in the urban water management plan. As someone has helped written urban water management plans and reviewed hundreds of them as we've gone through the cycle each time, there's nothing that really quantifies what's in there, and that they can put a desal plant in after the fact. In fact, in Orange County, they weren't there at all when we were looking at it. So with that, I want to thank you very much for the time.
Thank you. Yeah. Thanks for joining us both days as well. Amanzadeh, followed by Tom Luster from the Coastal Commission.
Good afternoon, Chair Marcus and board members. I'm Sarah Amanzadeh. I'm the Executive Director with California Coastkeeper Alliance.
Like Amanzadeh.
I just want to say a few words on behalf of the communities that are potentially facing desalination projects. I think so many people in this room today and in the dialogue around desal are project proponents or are consultants that are specifically tasked with necessarily advancing desalination. And as Connor alluded to, this is a larger issue about water management, and we were here yesterday looking at water conservation. And some of the issues around desal fall outside of the Ocean Plan Amendment. There are cost issues, there are energy emissions issues, and I understand that, but I just want to encourage the board to, as we move forward, consider the public trust responsibility that we have in looking at our water management. And really consider that as we move forward. Really empower the regional water boards with a robust framework to protect communities from what really are a very costly, a very energy intensive, and a potentially a very environmentally harmful water supply option. And board member Moore spoke yesterday about the need to look at integrated water management planning and really step back and look at the bigger picture. So even as we move forward today, I just encourage the board to really keep that larger context in mind and keep in mind the communities in Santa Barbara, Orange County, San Diego that are really going to be impacted by these facilities, impacted by the costs and impacted by the facilities. Thank you.
Thank you. Mr. Luster, followed by Craig Johns from Poseidon.
Good afternoon, Chair Marcus and board members. Before I start, I had requested just a couple more minutes, if you'll indulge me with that.
Just a few, because I don't want to run out on the last speaker.
Yes. Thank you very much for the opportunity to comment. Finally, We're here at your adoption hearing for the desal amendment. It's been a long, strange journey over the past several years.
You know, I almost started the day with that line.
Oh.
Maybe it's just true.
In
It's a
sync,
cosmic
yes.
truth. Yeah.
Your staff has been through a lot, and you've been through a lot of staff to get here.
Yeah, everybody's going to take Dominic out for a drink, in particular, when this is over.
But I'd like to acknowledge their thoroughness, their willingness to involve stakeholders and agencies, and to slog quite determinedly through the various difficult issues we've dealt with. I remember standing here several years ago asking you a few things: that you ensure the policy be consistent with other state requirements, including the Coastal Act, that it provide for coordination among stakeholders and the various reviewing and permitting agencies, and that you base it on good science and not scienciness. The current proposal does a pretty good job on these fronts. For example, we still hear about some scienciness, but we've moved past the era when some were telling you that using subsurface intakes would make fish stick to the seafloor. The policy, fortunately, does not incorporate that contention. At this point, I have two key concerns where I think parts of the policy could be strengthened. First, the board could require that intake selection be more strongly weighted towards sites that allow for any of the several available subsurface intake methods. And second, we would appreciate it if the policy more strongly acknowledged the importance of a coordinated permit review process. Regarding the first concern, this desal amendment provides the board with its single best opportunity to maintain and expand the marine life protections you established with your once-through cooling retirement policy and the California established with development of the Marine Protected Areas Program. More strongly emphasizing the need for subsurface intakes will add to those protective measures and will also likely lead to greater innovation in the desal world. One thing I wish we'd developed over the past decade or so was a better selection of pilot or test intake designs so that this issue was less of a sticking point. However, we have several good examples of desal facilities being done in a thoughtful, stepwise, and relatively drama-free manner, where the decisions about siting and technology selection have been based on geotechnical studies or on test and pilot data, and where the end product is not a foregone conclusion, but is or will be a product of those studies. I'll call out a few good examples: Cal-Am, the Sand City desal facility, the Doheny Beach project you heard about earlier today, all good examples. Even with the limited examples we have available here and elsewhere in the world, we're finding that subsurface methods not only avoid or minimize the intake and mortality of marine life, but can be more cost-effective and less wasteful than surface intakes. A very small change to the policy language, a couple of words, could make a much stronger statement by the board and could result in desal facilities that are more aligned with the state's goals of protecting marine life, reducing greenhouse gas emissions, and improving water quality. Regarding the need for increased emphasis on coordination, we appreciate that the policy recommends coordination amongst agencies and that it implies a certain permit order, but we believe the policy should make those components more explicit. As you know, we already have the state's interagency working group on desal that helps guide applicants through the permit process and that has resulted in some pretty quick reviews and permits. However, we also have examples of project proponents choosing to go through a particularly difficult or painfully inefficient process. With this new desal policy, the board has an opportunity to re-emphasize the need to conduct these reviews thoroughly and efficiently and to avoid further bad examples. This may be a particularly important message given the drought and the state's focus on new water supplies. I should mention, though, that despite being in the 4th year of the current drought, we at the Coastal Commission have a total of just one pending active coastal permit application for desal, and that's for a relatively minor change to an existing facility. This suggests a couple of things. First, that people are correctly not viewing desal as a fix to the immediate drought, and second, that right now we have an excellent opportunity, almost a blank slate, to establish through this policy a preferred type and level of coordination that won't adversely affect existing applicants. Why is coordination so important? Along with standard local permits, most facilities will need early approvals at the state level from the Regional Board, the State Lands Commission, and the Coastal Commission. Before a facility starts producing water, it will need approval from the State Board's Drinking Water Division. In some cases, it may need approval from the Public Utilities Commission. There are small areas of overlap among this group, but for the most part, they evaluate very different components of a proposed project. For example, both the Coastal Commission and the state and regional boards will weigh in on conformity to this particular section of the Water Code, 13142.5B.
Hey, you know, you're not going to get the drink.
The pressure was on.
Like everyone else. And my apologies to Mr. John, and my apologies to you that I can't stay, but I do have a hard stop, and I will count on my colleagues, you decide who, to write very detailed notes on the rest of what you have to say and what Mr. John.
Thank you. But both the Coastal Commission and the boards will be weighing in on that section and will determine how to best minimize entrainment. To ensure an efficient review, this requires the Commission and the boards to coordinate and agree on the appropriate entrainment model to use, the appropriate mitigation ratios, and other issues. In addition, though, the Coastal Act and its associated local coastal programs cover a much broader array of issues, such as making sure a proposed project is consistent with land use requirements, that it ensures continued coastal access, that it addresses coastal and geologic hazards, and protects sensitive coastal habitats and others. These are outside the purview of the regional boards, but the Commission's determination on how and whether a facility addresses these issues is an important part of the board's consideration when looking into a facility's site design and technology choices. I understand from your staff that the board is hesitant to include in the policy a required coordination method, and that the preferred approach would be to establish instead a memorandum of agreement that describes the expected type and level of coordination amongst agencies. I'm pleased to see that the board's proposed resolution directs your staff to start working with the Commission and other agencies on an agreement that better identifies how we're going to coordinate the implementation of this policy. We accept this as an appropriate approach to address this issue and look forward to implementing this policy with you and the regional boards. With that, I'll close and be happy to provide any additional information, regale you with tales of colorful anecdotes of desal, or answer any questions you have. Thank you.
Thank you for being succinct with those 2 points. It sounds like the resolution language that staff proposed addresses your second point. With respect to your first point, you had said in your comment that with a few minor changes, you believe that area of the amendment could be strengthened. Do you have any specific word changes?
Well, just a couple, actually. You heard the rebuttable presumption discussions earlier today. That's one possibility. Another one would be on the May 5th draft, page 5.
Hang on, let me get there. Okay, page 5.
B sub 1, change consider whether subsurface intakes are feasible. Consider any sites where subsurface intakes are feasible, something along those lines. Or consider all nearby sites where subsurface intakes are feasible. That would help strengthen it as well.
Sorry, go back again. I'm on page 5. E?
5B1 is the sub 1. It's the first numbered bullet at the top of page 5.
And your recommendation is to?
Delete whether and replace that with either, quote, any sites where, or alternatively, quote, all nearby sites where, end quote, subsurface intakes are feasible. Something along those lines.
Thank you.
I did have one question. Have you looked at the deep water proposal, or are you familiar with that particular effort?
We've had a couple meetings with the project proponents and one multi-agency meeting to discuss the project. And I've reviewed some of their studies, yes.